When you look at a PIC microcontroller, you'll see the plastic package and the metal I/O pins. But inside is the core microchip, and that gets connected to the I/O pins through little bond wires. Well, there are times when you're designing, especially when laying out a circuit board, you may need those connections to be at a different arrangement. Well, that's where Peripheral Pin Select comes in. Through software, you can rearrange some of those pins. The Peripheral Pin Select is available for digital peripherals. It uses multiplexers to select its input connections and its output connections to the I/O. Let's look at the input connections first. Each peripheral has a peripheral input selection register to select the input connection. Each I/O pin is assigned a 5-digit code, and by placing the correct 5-digit code into the peripheral input selection register, that pin is selected as the input. In this case, we've selected the RC5 input. Here's a couple code examples where the receive input is connected to the RB4 pin, and an assembly example where the external input is connected to the RA3 pin. Now let's look at the output connections. The output connections use an output source selection register for each I/O pin. In the case of the output, each peripheral output is assigned a 5-digit code, and that code is input into the register. For example, for C1 out, we would enter 10110. Here are a couple code examples. The first one is in C, showing the transmit output connected to the RA0 pin, and the second one is in assembly, with the CLC1 output connected to the RA5 pin. Setting the PPS locked bit to a 1 in the PPS lock register prevents further changes. And there's a specific procedure to do that. The first step is to disable interrupts. And then the value of 55 hex is sent to the PPS lock register. And that's followed by a value of AA hex sent to the register. And then a value of 0 is sent to the register to clear the PPS lock bit and unlock the PPS. A similar procedure is used to lock the PPS. First, a value of 55 hex is sent, followed by AA hex, and then a value of 1 is sent. This sets the PPS lock bit and locks the PPS peripheral, and then all interrupts are enabled. The PPS1 way bit in the config2 register can be set to limit the PPS lock bit from being set only once after a power-on reset. Once the PPS lock bit is set, it can't be changed. The MPLAB code configurator makes all this setup much easier. Within the pin manager, you can select the pin and its connection to the peripheral by clicking on a little lock symbol. This will help us to set up the code. Once the I/O connections are established, we can click on the Generate Code button, and the code configurator will produce a pinmanager.c file. Within that C file are all the code for the Peripheral Pin Select setup. There'll be include files, and then there's a pin manager function that has all the setups for the I/O, including the latch register, tris registers, and cell registers, and pull-up registers. Then it will go into the PPS lock sequence and unlock the PPS bit. Then all the I/O selections are set up in their register settings, as you can see here. For example, the RB4 pin is connected to the PM3 out. And as you step through each of these, you can match it up to the selections that were made earlier in the pin manager. Then the last section of code goes through the sequence to lock the PPS lock bit. Here's a very simple example showing the port A1 pin connected to the PM3 output. The code configurator produces the unlock sequence, then the register setting for the RA1 to PM3 connection, followed by the lock sequence. As you can see, the Peripheral Pin Select is a very useful feature. This concludes our training. For more information, please go to www.microchip.com/developerhelp. Thank you for watching.